Okay,
It's
so
all
in integration, and remember, integration management is that overarching chapter that you probably want to go back to at the end of all your reading and read it again and say, wow, now all of this makes a lot more sense because I have the stakeholders, the risk, the procurement, all those other bits that that hadn't been talked about before in the PMI context. So what we want to do is we want to define project integration management, identify the key roles, explain the selection methods for projects, describe the integration processes, and look at key terminology. So we're going to get right to that. And project integration management includes the processes and activities to define, combine, unify, and coordinate the various processes and project management activities. And that is a specific definition from the PMBOK of project integration management. So that is probably something you really want to know, because if they gave you that definition, would you be able to put that with the appropriate knowledge area? So again, this is the high-level work that the project manager does to manage the interdependencies among the other knowledge areas. So this is kind of the spine, if you will, and then all the other parts are the muscles and the tissues and the limbs and whatever, you know, hanging off the skeleton. So project integration management includes the allocation of resources, balancing complex demands, especially dependent on your organizational structure, looking at alternatives, because the way to really understand something is to be able to understand what alternatives there are. Often if you can just see one way through, that is probably not the only way through. So you really understand something well if you can come up with some good alternatives. Again, tailoring processes to work within organization and project needs, and managing the interdependencies among the knowledge areas. So again, this provides continuity across multiple knowledge areas. And for projects that are iterative in nature, you want to ensure that deliverables and due dates are achieved, and even if you're not iterative in nature, even if you're waterfall in nature. Again, you want to provide a plan for management. You want to ensure that you've got all the knowledge you need when you need it, because often the right answer too late is not the right answer. You want to manage your performance of effort. You want to constrain change to the project, which doesn't mean you have to say no change, but you want to be very measured in the integration of changes. Again, you want to have decision making across the knowledge and process groups integrated so everyone has the same basis of information. You want to identify and collect work performance, because remember, we're going to use that to collect, we use that raw data to turn it into information and reports, as well as to monitor and control. And we're going to implement your risk strategies, again, which will be talked about later, manage communications and engagements, again, later, and effectively manage phase transitions. So first we're going to talk about the role of the project manager, team, or sponsor. So the project manager integrates the various activities of the project, hence the knowledge area name Project Integration Management. And the key role of the project team is to complete the project activities. And the project sponsor is the person who the project is being performed for. So that could be someone internal if you're doing some kind of, say, internal process improvement, or it could be some kind of external if you bid on a contract and won that contract. But you've always got to be aware that, and all of these people are obviously stakeholders, but the stakeholder group is not limited to these stakeholders. Okay, next, how do we select a project? And a project can be undertaken for a number of reasons, and you know, it can be business needs, and there should be a formal process. And remember, we talked about before that there could be technological change, there could be regulatory change, and we want to make sure that the use of resources is optimized. So broadly, we can say that we're looking at benefit measurements, and of course, the idea of a murder board, I think, always attracts people's attention when I teach these classes. And a murder board is the group that is kind of the thumbs up, thumbs down, kind of like the judges on Dancing with the Stars or America's Got Talent, whatever. And basically, they are out to murder new project ideas if they're not good. So another way you might select projects is through peer review. There could be various kinds of scoring models. You might use economic models or cost-benefit models, and potentially use all of these kinds of benefit measurement methods. And then you might also do constrained optimization techniques, and this is mathematical modeling, and again, this implies that you've got a whole bunch of data on which you can base the mathematical models. But again, linear programming, goal programming, or integer programming. Not that you need to know any of those items in depth, just that those are constrained optimization methods. If you're interested, however, though, you can, Google those and look up further information, because it's always good to have more tools in your toolbox. But again, you want to understand the characteristics of the various selection methods to answer scenario kind of questions.
So these are what you're saying are utilized in looking at a project.
Well, they can be utilized. They don't all have to be utilized. And in fact, you might use a completely different set of selection methods, but these are potentials. So as long as you understand that linear programming is a constrained optimization method for project selection, that's what you really, as a takeaway from that line on this slide, is that's what your takeaway.
Okay.
Okay, so for instance, there's a question, what type of selection technique is peer review? Well, peer review is a benefit measurement method, as we saw over here. Okay, so we're going to talk about a couple of these ways to measure. And present value, or PV, and unfortunately that's an overloaded acronym, so that's another thing you need to be careful of when you're looking at test questions. And we're not going to talk about the other PV right now, but just saying that sometimes when they use acronyms, they are overloaded, and you've got to understand by context which acronym they're really talking about. So basically, it's the current value of future cash flow. So when I said you need to know some economics, here we go. And in fact, that was one of my undergraduate degrees, so now I'm going to really nerd out on you. Just stop me if you need a break or something. But basically, the amount of money received today is worth more than the same amount of money in the future, because would you rather have me send you $100 today, or would you rather have me send you $100 6 months from now?
You want it today because the value is higher. We don't know what the future value is of that $100.
Exactly. Perfect. Okay, because so basically there's a discount factor, and even at our 1.0 or 0.1 interest rates, there is still the current value of money. Money now is better than money later. So present value analysis is important to ensure that you maximize the profit, particularly over a long period of time. So the farther the timing is of the cash coming in, the lower its present value is. Okay, so the next thing is net present value, and that's the difference between the value of the total income or revenue and the cost over a period of time. So present values of different items combined give the net present value. So if we look at a project that'll take 2 years to complete and has a net present value of $35,000, and again, they don't want you to calculate the net present value, you'll be given that. And project Y will take 5 years to complete and has a net present value of $95,000, you would obviously select project Y because it has a higher net present value. So in all cases where they ask you about projects, the one with the higher net present value is always the better one. So that that's fairly straightforward. But again, if you're creating a brain dump, and I don't know that I've said this enough about when you take the test, you should probably have some key formulas and term definitions and things like this. Net present value, you take the bigger one. That you have, one sheet of paper's worth, and immediately when you get to the test and you've got their blank sheet of paper, write down all those things on your brain dump first thing, because that way 3.5 hours into the test, when you're thinking, wait a second, was this one greater than, or did I take the least of them? You'll have all those written down, and you'll have the formulations too, because again, as some of the multiple choices go by, they will throw some incorrect formulations at you, and so you don't want to have those drummed into your head and apply those later. So during the course of this class and during the course of reading and studying, you may want to create a brain dump of things that you need to use or that you need to look up, because of course the best way to study is, you know, when you're taking, say, when you start taking practice tests, you might want to look up the information so that you're practicing perfectly and not grooving in some incorrect information. So net present value, always remember, needs to be the higher of the two. Okay, next is internal rate of return. And internal rate of return is discounted cash flows, kind of like an interest rate. And so basically, if you have the choice between an internal rate of return of 25% or an internal rate of 15%, you'd choose 25% because it's bigger. So for internal rate of return, bigger is better. Now next we get back to payback period, and this is the number of periods it takes to recover an investment from the project before the profits start accumulating. So especially, you know, if we were in project management 101, we would talk about, say, places where the political environment is such that maybe you'll be kicked out of the country before, you know, you go 100 years or 10 years or whatever. So you want to make sure you get to your payback period before.
I have not done these calculations in, oh my goodness, a long time. I haven't had to.
Well, and that's okay, because you don't have to perform the calculations. You just have to understand that for net present value and for internal rate of return, that bigger is better. But for payback periods, smaller is better.
That's right.
So no, you don't have to carry out the calculations. You just have to understand that if you had a 5-month project, a 5-month payback and a 12-month payback, you want to pick the 5-month payback because obviously you get to making profits sooner. So
I'd like to start utilizing this again, but they haven't done projects like that here.
Well, and that could be very good, because maybe you're not doing projects in areas where, you know, eminent domain might take your project away or something. But at any rate, just, you know, just be able to know for these kinds of things, you know, bigger versus smaller, you know, which one you want to pick. And again, this is probably something you'd want to put on your brain dump. And if you come up with this, well, I might be nice, but if you come up with a sample brain dump during the class, then I will send you some samples of brain dumps that I've come up with, or that, you know, good ones that I found from the internet. So hopefully that will incentivize you to develop a brain dump. But maybe next Wednesday or 2 Wednesdays from now, or whatever day that is, I might just give you a brain dump, because it is a very useful tool to have. But if you make it your own and tailor it for the things that you remember or the things that you need to know, it's usually better. And you do have to practice writing it down. Okay, so next we're going to talk about benefit-cost ratio. And the benefit-cost ratio looks at the present value of benefits to the present value of costs. So if the benefit-cost ratio, so it's benefits over cost, if you think of it like a fraction. So if it's bigger than 1, that means the benefits are bigger than the cost, and that's good. But if it's less than 1, that means the benefits are less than the cost. And of course, here you're contributing all of the factors that contribute to benefits and all of the factors that contribute to costs. So, you know, whether that be goodwill or you know, as a benefit, or just spoiling the environment as a cost, you know, that's all factor. Everything is factored in, assuming that in the benefit-cost ratio, everything's factored in. So if it's less than 1, that means you've got more costs than benefits, and you shouldn't do it in any case. And if it's 1, it's kind of a toss-up. So if you had a choice between a benefit-cost ratio of 2.5 and 1.5, again, you're going to pick project A because bigger is better. So just remember, for benefit-cost ratio, bigger is better, but you never want to pick anything that is less than 1, because the net benefits are less than the net costs. So, you know, that's fairly straightforward in terms of bigger is better, but then it, you know, also has a hard stop at 1.